Before you deploy the combiner box in the field, I would highly recommend you do some tests on the box beforehand. In the documentation that was provided by YCCC, on page 29 and 30, John's provided some really great instructions on how to perform two different tests, one using just an antenna analyzer and another using an optional VNA. I'll show you both what I did, but the reason I want to go through this is really it's very well described. You could do it on your own quite easily, I'm sure, but because my board has an integrated amplifier on it, you can't quite do it exactly as it's described by John. And specifically, with respect to the impedance analyzer test, I mean, you could use any kind of analyzer, an MFJ 259 or one of those AR55 zooms, or whatever you have on hand. Really, you're just looking for S21 impedance measurement. But really, it's very, very simple. You're testing one of the three vertical antennas, which are the ones that are always in line, independent of any voltage applied. That is the center port, northeast, and southwest, together with the receive port. And essentially, you will always terminate any of those unused ports that aren't being analyzed with a 75 ohm resistor, and you'll be testing and sweeping the analyzer on the other one of the other ports. And so the one thing to be very aware of here, though, do not apply power to the box at any time during this testing, because there is 12 volts supplied on each vertical port. So if you've got a 75 ohm resistor across any one of those vertical ports, you're going to heat that 75 ohm resistor up pretty good, and there's a high probability you'll toast the RF chokes, which are on the combiner board. But here's the difference, and the reason I want to show you this is because I have the amplifier integrated onto the board. We can't really do it as John describes, and that is to say, just connect to the RF out port, because of course we have the amplifier in the line here. Of course, if you've designed this without the amp, of course, proceed along. It's quite simple, to do it the way John describes. But I mean, it is the same testing, but we just have to eliminate the amplifier. And I've provided a test port here. You'll see I've got two test port pins. The yellow arrow is pointing to the direct output from the output transformer of the combiner. The other test port is ground. And so this provides us access to access the receive port. Now, before you do any of these, before you install C1, okay, the coupling capacitor that couples into the amplifier, don't install that capacitor until after you've completed the testing. The reason for doing the testing, I must say, is because if there's going to be an error made on building these combiner boxes, I would submit it's likely to be the transformers, either winding them or getting the pin out wrong. So I think it's worthwhile doing these tests. So anyway, this is how you'll access the either if you need to put your analyzer on here, it'll go from test port to test port, or you will put your load resistor here, which in this case will be a 50 ohm resistor, not a 75 ohm resistor, because of course this has been designed with a 50 ohm output transformer. So here's the tests I did. So in fact, this is the output from the receive, where it's going into the 50 ohm 2N5109 amplifier. Of course, the other terminals, the northeast, southwest, and center ports are all terminated in their characteristic 75 ohms. I did the sweep. I'm using my Nano VNA, by the way, and you can see that it's 59 ohms, or rather 49 ohms, very close to what we should expect, which is 50 ohms in this case. Here's the southwest port, and again, in this case, I have all of in this case, I have the center port and the northeast port terminated in 75 ohms, but I've terminated the receive port in a 50 ohm resistor, right? And so I see 75 ohms, which is exactly what well, 75 and a half, pretty darn close. Same thing with the northeast port, 75.6 ohms. And the center port, same thing. If you've made an error with the winding those transformers, you're going to see it here, and then go back and do some forensics on where the problem may be. One other test I did do was I also confirmed that the input of the 2N5109 amplifier is 50 ohms, which it should be. And I've tested this many times before, but we terminate the RX out from the amplifier in its characteristic 75 ohms. In this case, we power up the amplifier, and I swept the input, and you can see it's 50 ohms. So got a perfect match there with the output of the combiner box to the input of the amplifier, which is precisely what we want. I'm going to show a few videos where I swept the both the original YCCC box that I purchased from DX Engineering, where I do a VNA sweep as described by John. I did this in the field, so I made a couple of videos, and I'll show then a couple of videos where I sweep the new box, the homebrew box, just to show you how the phase and the gain is matching what should be expected. Having said that, if you don't have a VNA, a two-port VNA, I don't think it's entirely necessary. Just be very careful when you cut the delay lines.
So I decided to do the full VNA sweep as described in the documentation that I've referenced before, and it's a pretty ugly setup, but I'm actually out in the field and just huck this onto the bench and have it set up as per the documentation. As I say, page 30 gives you a lot of the detail. Well, actually it's page 29 and page 30. But I have the my Nano VNA connected to my laptop here, and as described, I have both the southwest port and the center port terminated in the characteristic 75 ohms. I just used a blank F connector with the resistor stuck in there. It's a quick way to do it. And I've properly terminated and done a through test also with the VNA to make sure it's properly calibrated. Anyway, doing that test, this is the original YCC unit, and you can see that as per the documentation, I'm pretty close, minus 5.631 dB for the S21 gain, and that's what it should be. It should be exactly minus 5.6. The phase should be on the northeast port, which this is. It should be minus 160 plus or minus. Well, I'm minus 158.75, pretty good. And that's on 160 meters. On 80 meters, they suggest it should be minus 140 degrees. Well, I'm 139 degrees for the minus 139 for the S21 phase. And the gain also, again, minus 5.52, so pretty darn close. So anyway, that's about what it should be. I'm going to do the same on the other ports, make sure it's consistent. Then I'm going to test my new design board and make sure that it's consistent as well. All right, did a sweep on the southwest port. And you can see that we're still really close, minus, in this case, plus 159.5, pretty darn close to 160, which is the ideal desired phase. And S21 phase on 80 meters is exactly 140 degrees. And the gain is also right about where it should be, minus 5.6 dB. So anyway, basically confirming, indeed, our delay lines are accurately cut, and the gain is properly balanced as it should be. Okay, I'm doing the same test now on the new combiner box. Of course, I did a calibration. It's important to do. Kind of an ugly setup here. As I explained earlier, it's a little more complicated in this case because of the integrated amplifier. So I've used the jumper to connect directly to the output of the transformer before the amplifier. And of course, in this case, it's 50 ohms, so it makes the calibration a little bit easier. Anyway, I did the sweep, and it looks pretty much identical to the other one. Well, which it should. I mean, we're using the same delay lines, minus 158 degrees for S21 phase on 160 meters, and the gain is exactly minus 5.63, so right on, and pretty much the same on 80 meters as it was with the YCCC box. It's a minus 139. Should be minus 140. Heck, that's close enough. Minus 5.57 dB for the gain. Looking pretty good. Do the sweep on the other port here just to make sure we're good there too. All right, here we're doing the VNA sweep with from the RX port to the southwest port instead of the northeast. And of course, in this case, the northeast port is terminated in 75 ohms, and exactly like it was with the other box, minus 159, or rather plus 159.6. Pretty good. Gain is, a little, maybe 0.1 dB off, but pretty close. Same on 80 meters, looking pretty good. That's exactly 140 degrees, which is what it should be. All right, looking pretty good. I think this is ready to put her out in the field.
Well, once you've deployed the box and constructed the full array in the field, what should your on-air expectations be? What I've noticed is you really should see some significant front-to-back performance on the array. What I found very helpful to see that is on 160 meters. During the summer months, especially, there can be very prominent thunderstorm activities in the U.S. Midwest, and they're kind of from our location here in V6. They're almost pinpoint like to the south east. And switching the array toward those or away, it's almost like a switch. You should really see significant front to back. And if you're not, then I think perhaps that there could be something could be problematic. In fact, this is the modeling which was comes out of the good work that John W1FV did. I've also modeled the array. I put it into 4 and EC2 and get the same pattern, and you can see the very prominent front to back evident on this azimuth plot. Though again, we're not so focused on front to back specifically as much as we are on RDF, the received directivity factor, and indeed it's very significant. The RDF on these antennas is great, and I've been very happy with their performance. Hope you enjoy the array if you build one. It's a lot of fun. For me, it's been a great project. 73, Steve, V6WZ.